Welcome, everybody, to the Good Data Podcast. I'm excited about this show. Today, we'll be discussing the Kinetic Edge. That's, I think, a new term, but it's this idea of putting small data centers very close to the users and then being able to move data between these data centers invisibly. So you would install many hundreds of these mini data centers and then shift virtual resources between them. And when you do that, each individual one doesn't really need to be that robust, but when they all work together, they provide reliability. And it's kind of like a Wi-Fi mesh concept. And I've been talking about this with my partner Kevin for years and years, but now there's actually some traction in the marketplace, and I've invited Kevin Farnsworth on to discuss this concept and see what the future might hold. Let's go. So here's a blurb from the Kinetic Edge Alliance, which is a alliance that was put together by a company called Vapor.io. And here's the quote that they put together about why the Kinetic Edge Alliance is necessary. Edge computing will deliver the next wave of network and data center infrastructure vital to support 5G, autonomous vehicles, and many other exciting technologies and applications. To meet the needs of the future, our industry must collaborate. We must bring together all of the products, platforms, and expertise needed to help make operators and developers successful with edge deployments. So there are a number of companies that have signed on to this Kinetic Edge Alliance, and some of them are large, some of them are influential, and I will be very interested to see how that develops and what it will mean for the industry. So without further ado, let's go on to my conversation with Kevin Farnsworth. So we're talking about Kinetic Edge data centers, the Kinetic Edge Alliance, and the idea of having data centers that are real close to the users and why that would be important. I'm here with Kevin, who is my partner in our business, and we've been talking about this for a very long time, and we've been really excited about it for a really long time. But it's hard to make the business case, and we're still trying to see if it really makes sense. But there's so many things that are very exciting about this edge data center, and we called it back in the day the distributed mesh data center. So Kevin, right. Welcome.
Thank you, Drew.
And what was the concept of the distributed mesh data center?
Well, we've been working with data centers for 12 years in our business and years before that. And the idea was that we had been working on reliability of data centers so much. Yeah, and if it's possible to treat each data center as a backup to other data centers, you could create a mesh, and we referred that as a distributed mesh because it'd be a number of small data centers located. They kind of backed each other up. Now they call it, what's the term they call it now?
Well, these guys, Vapor.io is a company that's partnered with Crown Castle, and they came up with this term called the Kinetic Edge. So the idea is putting small amount of resources in containers real close to customers, and similar thing where they would back up to each other, and if one fails, it would back up to two others or whatever it is. And the reason they called it kinetic is that the workloads would move as required. Right. So it's like you almost think of it like a cell phone tower that you would, as you're driving your car or something, like if you were to be playing a cloud-enabled video game in your car, the video game would follow you. This is right. Just my thought of it.
Obviously not when you're driving, but maybe you're
you're a passenger, yeah. But it would follow you from one of these edge data centers to the next and the next. At least that's that's a use to it. But also, like you're saying, if one fails, it would move to another spot.
Yeah, one of the understandings of the original concept was that getting the data center as close to the user as possible. So under normal conditions, even under like static conditions, they have access to very significant data storage and data processing right at their fingertips. We thought that would be good. And then also that if other, like let's say a university or business or a school had these located close to them, and they were all interconnected to create what we're referring to as a mesh, then the reliability of any individual unit wasn't as important, because as we design data centers, reliability is everything. So that was my idea, that you could build something that's fairly small, fairly compact, but many of them, and locate them in important locations for the client, but the client would always have a backup because they would be backed up to other units. So I think it's the same concept. It's just how now with the Internet of Things, then this is going to happen. I think it's just how much capacity each of these locations has, and how these guys treat it and how we would treat it.
So the funny thing about it is that we didn't use the term edge at the time,
right,
because we were mostly thinking about reliability, and also, one of the things that I really like is the ability to get these things smaller and smaller, and maybe someday get one of these pods to the point where you could just put it on the back of a trailer and take it away to service it, and just put another one on where it was,
right, so
that you're always doing the work in the factory and you don't have any field work. But this idea of edge with data centers like Edge Connect that take these kind of tier 2 markets and they put their data centers there so that they can get things like Netflix to their users with real low latency. So, they use the idea of the edge as for like CDNs, for content distribution networks and things like that. But that wasn't really our reasoning for it. But,
no, not originally. But
yeah.
that was a couple. We did this.
That was a long time ago.
We're talking about 3 years ago or so.
More than that.
Well, we first kicking around, but we wrote
8
papers on it.
Yeah.
3-4 years ago, and just because we were thinking about it, and since then, the whole idea and the technology has improved to the point where it's happening. It's not a matter of, it's no longer conceptual. It's happening. It's just how quickly it will happen, and I think that the idea of the cellular interconnect with Crown Castle is important, because they already have a distribution points, and the Wi-Fi and the that's going to make a big difference as well.
Yeah, that's so Vapor.io. I'm not sure what they call themselves, but they partnered with Crown Castle to actually put their little micro data centers at cell phone towers so that you could get really low latency at that spot. And that they're currently working in a few metro areas. They have a plan to roll out to like 30 metro areas. I think one of the closest to us is Pittsburgh. But they have like Dallas.
Well, it's interesting, in Pittsburgh is where my associate had been doing the work,
yeah.
and he may be involved in that.
Maybe.
And I'll check with him.
Maybe.
On that.
So, yeah, the idea of putting it at the cell phone tower makes a lot more sense as you move to things like 5G, and you have a lot more data going through the cell phone tower as opposed to over the regular internet pipes. So the idea of the customers are Internet of Things, and I think video games.
I think video in general, not just games, but digital imaging is everything in the future. It's already big now, but
yeah. The question for me is, video specifically, you have a lot of data. You have just these big video files that have to sit someplace. So does it make sense to how many videos are you going to put like right at one of these tiny pods, and how many would you put in a bigger data center, and would you move them back and forth? There's
caching. That's the whole idea. I thought that the pod would have the caching, if that's the right term, of videos, and then as soon as it was requested, then the transfer of data from a data center or a larger storage location would come into the pod, into the the unit. Though the initial would have very low latency, and by the time that you got through the first few minutes, that you would then all of that data would be transferred down, so the rest of the video would have been available. And I'm, again, the technology of that I think is very.
Well, I think the technology is already pretty baked. Like, right. Netflix is very good and they do have caches of like the first minute of every program or something, so that as soon as you click play, it'll get to you as fast as possible, and then they'll kind of download the rest of it more slowly. And
I mean, we have Netflix on Verizon, fiber, and we still get hiccups on that.
Yeah.
So I think that over time that that's going to improve with this concept, because you're going to have a lot more things to select from, as a stationary, but also, as you say, a lot of the Internet of Things, the driverless cars or the other things that, trucks particularly moving around, is going to happen. So it needs that infrastructure to be available to make those things happen.
Yeah, it's one of those things that it sounds great to have the least amount of latency possible in any given thing. And the idea of getting it as close to the customer as possible is the hallmark of the edge. But the question is, how close does it need to be? And is the current kind of edge, where you're at places like Edge Connects that are maybe one that's in Kansas City and one that's in Topeka, Kansas or something, versus having one that's in each cell tower at each one of those places, and do you actually need to get that close? Because in terms of, I'm playing devil's advocate, but because I believe in it too, but in terms of certain types of applications, you already are at the kind of simultaneous, invisible to the user type of input-output that you would want for a lot of that stuff. It's like, how much more do they need by putting it closer? And that's one of...
I mean, the thing is, I think it has to be done for multiple purposes, not just for the latency issue. I think you want to do it so that the data and the application has a wider footprint, and hopefully in time, and especially as we're talking about high performance computing and using these spaces to be very, very dense data centers, essentially in a box, that we can get a little bit further away from the mega data centers. They're important, they're going to have to be there, but not necessarily the way they are now. And especially the end user. I mean, we, as you and I know, that the enterprise data centers, the users' data centers, are shrinking tremendously between cloud and co-location and all. And we're finding that, at some point, they will not need to have virtually any on-site data center, other than connectivity. And, the closer, the more distribution, the more kinetic data center capacity, the better they'll have connectivity and access to their applications and their data. So the cloud's going to kind of absorb all of this as well, I would imagine.
Well, yeah, I think for the failover that we're talking about, it would almost have to have an architecture that would be similar to what we call cloud, because you can't just take a normal Windows server and have it fail over without having some kind of big architecture behind it. Whether that's even I think the disaster recovery as a service type software doesn't let you just shut it down and spin it up as quickly as you would need to, like we're talking. So you would need something that is at that kind of like, the level of sophistication of Google or Amazon or something like that.
I don't know if there is a term called the fog, but...
yeah. that, I think it's a silly term, but yeah, that is out there. Yeah, that bringing the cloud as close to people as possible. I don't know if that term really works, but yeah.
The idea of the cloud, because a lot of people don't understand what the cloud is or cloud computing is.
Well, I don't think you can, because there's no specific definition. So right. It's like,
but people use the term continuous, all the time. Oh, I'm going to go to the cloud, and they're really thinking AWS. I mean, that's kind of the services that AWS provides, but there's so many other options to that term cloud.
Well, and the thing I think about AWS even is that that's not even well defined. There's so many different offerings within AWS, but getting back, so I think some of the needs of this, you would need to be able to fail any one of those data centers very gracefully and quickly, or at least switch from one to another very gracefully and quickly. So to me, that requires you to have great connectivity and great management software to manage the whole engine of it, not just the sort of facilities, or what you normally think of as facilities part of a data center, the cooling and the power and all that. So if something fails at that one, you can fail it over easily, but also the software to be able to move the workloads where they need to be.
I mean, that's where the simultaneous replication is what we're kind of talking. I mean, I don't understand what that term means because I'm more of a facility guy, but in concept I do. So if you're because if it gets hit by a truck, kind of that's the mindset is all of a sudden this box is no longer available, but the user is connected to the internet and they will be able to see their data instantaneously from another source. There may be a slight delay or slight hiccup on it, but they don't lose any productivity. And that's the bottom line is, businesses cannot lose productivity and connect. I mean, that's where our clients spend a lot of money to be able to have continuous connectivity to their data. And I think that's going to become a strictly a utility. And that's as you distribute power, you distribute other things, that this will be a distributed utility that's happens to be located in, there's not, I think it's even more dense than cell towers, but, once 5G gets going, which again, I don't quite understand what the 5G really is, but I know that it's revolutionary.
I forget what the definite definition of 5G, but I like to think of it as just a gig over the air. That's my sort of shorthand personally, which I don't know if that's right, but that's sort of my conception of it. So if you say, LTE is like 27 megabits per second, and you're multiplying by more than 100 times to get to, really, really fast internet over the air.
Do you anticipate that eliminating the actual physical connections to homes and businesses, or is that that would still be, if you want 10 gig, you would need to have that connectivity.
Yeah.
But most residential, they definitely don't need that type of connectivity. So you can distributed, get internet connection through that without really getting, not having connect, and which gives it a lot more competition and all the other things, which, there's so many monopolies in the hardwired, Comcast, Verizon, in many regions, that if you can just say, I'm going to provide this and it's much more fluid, that means that it'll be a lot more competitive.
Well, right now, I think the problem with 5G is that there's not like a use case for it yet for most people. That's part of the reason why this is probably not quite ready for huge adoption, is that people don't use things that use more than 27 megabits per second. Like LTE broadband is good enough for watching video, and it's good enough for doing just about anything that people do, for the amount of data that goes back and forth. So that's why people talk about the autonomous cars and the Internet of Things and maybe VR or any of those kind of technologies that haven't been enabled yet, but they could be bigger. Because, that's the question. It's like, why do you even need a gig? Most users don't need anywhere near that. And even most companies don't need anywhere near a gig for each device. Most wall outlets, wall jacks at a given company could just be 100 meg, which has been the standard for 20 years, and they'd be fine.
That's interesting. I know, we know that the transmission of data is increasing all the time, and the demand for that. But as you say, the typical user has a laptop or a PC on their desk. The 100 meg is going to satisfy anything they do. Yeah. It's just the more sophisticated applications that now are in data centers, where they have very low latencies, and then they're cranking out a tremendous amount of data and resourcing a lot of storage. That's a bit different. And as you say, does this matter? That's the question. Is this technology, going to make an impact on the regular users and the regular businesses?
That's my big question. Today's episode is brought to you by Green Lane Design. Green Lane has been designing, engineering, and building critical facilities for over 10 years, including major enterprise customers as well as co-location facilities. GLD has designed and developed an integrated stack of design disciplines. If you would be interested in a free assessment, go to greenlanedesign.com, click on Contact, and mention the podcast. And you're opening up some risks too. In a security, you have to be okay with having less security at each one of these edge sites than you would at a big data center. So you have to make sure that everything is well encrypted, and probably not just encrypted on the one level, but your encrypted OS, you got your encrypted storage at rest, you got your encrypted data in transit, and so you have to have all these levels of security that might be even more intense than what would be at a regular data center. And you also have to think somebody could vandalize these things, or there's
if somebody were to literally put it up on a truck, what can they get out of it?
Right. You got to make sure that nothing gets out of it.
Right. Because
you put like a little GPS sensor that would call you
obviously
when something goes
wrong. Obviously, get all kinds of alarms, and it would send all kinds of signals and things. But I think that's interesting, because I think I would wonder how much the people who are building these things and pushing it, how much all of they have a foresight on what's going to happen in 5 years and 10 years. Is this infrastructure being built for some special purpose that we might learn about from some of the manufacturers of it? Because they're doing it. It's happening.
Yeah.
And we'd like to be, we've designed the pods. We've, have some of the understanding of the technology for the space, and it would be something we'd like to do. But, that's pretty straightforward.
Yeah.
Those people who are building these things have, I'd be interested. The one thing that kind of transitions this a little bit is this idea. I talked a lot about the high performance computing, and how to do that in a very sensible and low cost way. But I don't know that would that apply to this? Getting high performance computing in the
If that started to be a bigger deal, like let's say Alexa or Siri or a voice assistant got really, really smart and needed to have a supercomputer right as close as possible to you, or got even better than what it is today, then maybe it does make sense to have a high performance compute right near everybody. I think, as much as you might not think about it, Siri and Alexa and all those do actually take up processing power. There is artificial intelligence behind it. So taking that close to the user can make sense, because, people get annoyed just by the 1 second delay of Alexa. So getting that just a little bit closer is helpful. So maybe, I don't know. Is a 1 second delay enough to wreck everything? Or would this even help with the 1 second delay?
When they talk about a smart house, smart homes, they are becoming and smart businesses, everything is becoming connected. And as that happens, every device now you buy you buy anything, it has an electronic interface to it. I mean, my toothbrush literally has an ability to have an electronic interface that shows you how you should be brushing your teeth.
Right.
I thought that was crazy,
yeah.
But I didn't use it. But I saw it, and I'm like, wow. But there's so many things that are in homes now that come with those features, and that's just going to happen more and more. So I don't know that overwhelms anything, and that you need more connectivity or closer connectivity so that it's not burdening the system, because you have all of these devices hitting on some central database. That's it. But that is happening. The amount of things, the Internet of Things, is so much bigger than it was, and it's going to be astronomically larger from today on. So I guess this helps with that.
Yeah, but so the question is, does the thing itself have to be smarter? Let's say that processors have gotten more efficient, and we have Tensor cores, which is basically a chip that's custom made for AI, that we can put inside of some of these things, the Internet of Things, and then you can do that processing at the thing itself, and then you don't have to use the internet at all to do the processing for it. So there's the edge, and then there's the edge device that is actually gathering the information or whatever it is. So that back and forth, that yin and yang of where do you put the compute, it's real complicated. So I feel like I'm almost talking you out of the idea of it, but I'm just being.
I mean, in a way, we kicked this around for other reasons, and we weren't really looking at. We were looking at it more from a strict reliability and, kind of the economy of scale in reverse. I mean, the idea that we could reduce the cost of a data center by putting it in a box and doing it with very high efficiency cooling and distributing many of the boxes around, rather than building these, gigantic spaces that have to have super redundancy in them. And that's really where we started. Now it's gone to a different level now, but that's still part of it. That's still, I would be interesting to see how these boxes are being made and what the content is.
Well, so there's also maintenance, which is an issue, I think. Having these things in such a way that you could maintain them easily, despite the fact that you'd have to get a tech to drive to the location. So that almost definitely means that you're slower to act as you would be if there's just an on-site 24/7.
Well, that's true, but because you don't need it to be, you could remotely shut it down. You could have someone, as you and I talked about, someone go over, lift it up, put it on a truck, put another one down, start that one up, and nothing happened. I mean, no one knows that happened. You obviously have to have security on that way of lifting it, but whereas, and then all of the maintenance, the actual maintenance, is done in shops, not in field, and that's always been a problem. It keeps the reliability of that individual pod high without having to put the crazy redundancies in that we put into a typical data center.
Yeah, but the difficulty of having a lot of small things versus one big thing is that there does tend to be an economy of scale with the one big thing, because you just have fewer parts. So I think we keep going back to that sort of drop ship mentality of being able to just put something down, take it back to the shop if it's a problem. That's what makes the most sense to me. But so having something that's integrated, or a couple of integrated pieces that are really easy to interface with each other,
obviously standardization, using systems that are interchangeable, using the technology that can use one manufacturer, isn't locked into one manufacturer. That's going to be important, because it's basically you're talking about it could almost be on its own truck. I mean, you just drive it away.
It just has a little flatbed, or it's on a little trailer. And
you drive it up, you park it, and it's your data. It's this company's data center, and then but it's connected to all the others that back it up. So it's to be seen. I mean I know that the cell tower guys, and we've looked at designing those types of pods, and they're the little bit of a problem is most cell towers don't require a lot of power,
right?
So they're going to have to bring more power to that spot, and for these pods are going to require more energy, but that's not the utilities will get it there. If you're going to pay for it, they'll get it there. So
in a way, it would almost be easier though to up the amount of power required at a given cell tower by 100 kW than it would be to put 5 meg. If you have 50 100 meg of these things, then it's much easier to get that from the utility than to get one 5 meg service or something like that.
Yeah, I mean that's the idea of, and again, reliability. You're pulling it off different grids. You're pulling it off different, and you're not pulling in, as you say, 5 meg or 10 meg, or some of these data centers are 100 meg.
Yeah,
you're spreading that demand over, and as things like microgrids and DC power, and as they grow with the efficiency of the grid, having smaller pods that aren't these mega, that don't suck in incredible amounts of energy. Now there's always the efficiency side. Is many of these smaller things is like going to be significantly less efficient than one mega thing. Not that the mega things are going to go away. The mega things are still going to be there.
Yeah, because back to the kind of idea of the topology of having a bunch of these that can fail to each other. Well, what if a whole region goes down? Then you'd have to fail to something bigger that is much more robust. So you would still have to have that kind of backbone if this is going to be a 100% 24/7, 365 idea. Because let's say, is each one of these pods going to have a 24-hour fuel reserve? Is it going to have a 30-minute fuel reserve? If there's a regional power outage, what do? Are you going to run diesel trucks to each one of these things and just have a loop that is going back and forth? There's complexity to it that
I kind of think of it as of a spoke arrangement, so that you do have to have the home base, the place where things are stored and have the capacity at some place, and then you spoke out to these smaller things, and that hub location is going to be the mega data center or major data center that has tremendous reliability. But these individual guys don't need to have it. Now, as we're back to talking, well, is that necessary? If you have good connectivity to the hub data center, why do you need these little guys? And other than mainly the high idea of latency, but how many things are dependent on latency or affected by latency? Video gamers can only go so far. They're going to be the ones who really want no latency, and they're doing online video games, and they're so that's. But how many other obviously driverless cars want no latency,
right?
But they have AI in the car as well as looking at other maps and other things that they're going to pull out from other places. But how far along is that? And I think that the big push I've heard is the idea of having driverless trucks. Yeah. And that's a tremendous saving because they don't get tired.
Right.
Not that I put a lot of truckers out of business, but it's going to happen, and they'll need an infrastructure that is a lot more robust than the cell tower infrastructure. And that 5 gig and being able to get data transmitted to those trucks is going to be important for security reasons and a lot of reasons. If there's no driver, or a driver that can be sleeping while the thing's running and they're still there, but I think that's a big item. And so moving merchandise. Obviously, we buy more stuff online to get products to our property than we do I don't know if it's quite as much as we do in stores, but for certain products, it's or more online sales than anything. how to get that product to your facility or your company or your home. Obviously, Amazon's using drones to do it,
right?
And that drone needs to have a link to. Could very well use this grid to link to. So it's happening now. The question is, how do you find applications that are significantly improved by having this infrastructure available?
Right. And well, it's a good question. Sometimes the fact that something exists means that now there's going to be somebody who develops something for that. Like,
right.
People before computers, nobody was an applications developer. But once computers came along, suddenly there were millions of applications developers. And
look how many applications are on your phone because your phone's so smart.
So suddenly you have edge application specialists or whatever it is, and there are probably things that people could do that we haven't even thought of yet. Like, if everybody had augmented reality glasses and just walked around, and instead of a billboard, there would just be an optional augmented reality banner or some kind of art display or something everywhere you go. Well, that would probably require some of this stuff on the back end. And maybe if that was to be a case, like, if everybody had augmented reality glasses and it was just a part of culture, maybe then this would all be 100% necessary.
Well, I was chatting with my wife about, we're talking about a little bit of this, and we were actually talking about the chip. At some point in the future, now you have a watch. Why not have a chip? And that will be able to allow you to buy things. You don't need cash. You'll be able to know your health situation at all times, that can be transmitted to your doctor, or now that can be done somewhat on a watch. You can get your heart rate and other, even blood pressure, some devices. So this is all things that could be added to those applications that would require low latency and availability, a kinetic availability. So as you say, as these developers, if you have a platform, as you have an interstate, you're going to use it for something, and it was built, and now I think we're behind on the 5G from what I understand, but with this kinetic, that may help with deploying 5G faster than. But as you say, if it's not something that people are really looking to use, and then people aren't going to put the money into it until there's a demand for it. Right. So it's kind of, if it's there, they'll use it, but you have to justify getting it there.
Right. I mean, there are now 5G phones. They exist, but who cares?
There's no 5G infrastructure, so it doesn't really matter.
Not only that, but like, what are you going to do with it? You can't watch any better video. I mean, you're already watching video that looks fantastic. There aren't too many applications that I know of that require that kind of bandwidth for everything. And that's not to say it won't happen, but codecs have gotten better so that the actual amount of data transferred for video is a lot less. The compression has gotten better, and the way that you process the data on your cell phone is changed. And now we have AI chips on cell phones. That's a lot of that's for like image recognition or whatever, but still, there's no reason to think that would slow down. So my big question with this still, there's both the difficulty of it, that there almost has to be like a whole infrastructure in place, or like an ecosystem in place to make this all make sense, to be able to service, to be able to get the software what it needs to be able to make sure the security is what it needs to be, have the bandwidth how it needs to be. There's a lot that needs to happen for this kinetic edge or distributed mesh data center for it to really work. And that's, so these guys at Vapor.io made something called the Kinetic Edge Alliance, which is a group of companies that are all working together to create the ecosystem that's required to make this kind of a thing make sense. And I think it's a good start. But, identifying the problem is a good start. Thinking about, okay, so we need to have fast, graceful failover. We need to be able to move between locations really quickly, have great connectivity. The other thing we didn't really talk about is, could these be just as efficient as a large-scale data center? And I think, with technologies like immersion cooling, I don't think there's any reason to think that they wouldn't be.
I think that, you and I know the technology to make them extremely efficient. And, in certain locations, there can be, a cell, a solar cell, array near that unit and provide power that way. And since you can run things on DC power without having to convert from AC to DC and back to AC and back to DC, through UPSs and things, you can save a lot of energy just on the distribution side of power to the devices. And we've done efficient cooling to the point where your power utilization effectiveness is very low. PUE is very, very low. Because you don't necessarily you don't have the UPS redundancies, which have tremendous failures. You don't have the distribution redundancies because you're redundant from a network point of view. We can make we or they or whoever can make these tremendously efficient. But they make big data centers efficient, and the economy of scale for big data centers, of cooling towers and other methods, economizers, et cetera, have gotten much better in some cases. And some people, I still think it affects mostly the end user, not necessarily the residential end user, but the business end user, that they can really nearly eliminate the need to have any data center on site, that this is close enough and has, all their bells and whistles are available to them without having to spend the millions of dollars it costs to build a data center or run, and all of the expense to run a data center.
But doesn't Colo do that too? I mean, Colo or cloud or all those things.
I think I would call it, this is part of the hybrid. I mean, this is,
right.
Yes, Colo has an app, is important for this. The cloud is very important for this, but, the home data center, which is, people still need for certain applications and certain things, can be, a data center box that has, at your site, and got tremendously low latencies for certain applications, and maybe high performance computing for things that are running analysis. It's yours, but it's also shared. So your cost of owning that is so much less than the cost of owning a 5,000 square foot data center in your building.
Well, yeah, we haven't even talked about, I think one of the things you're getting at is desktop as a service, right, where you no longer have any actual software on your laptop or whatever device you have. It's all just in a data center someplace. So that is latency dependent.
And it's latency dependent because so many people are working from other locations than the office. Yeah. Both, other client locations, at home, there's so much more of that happening. And, they need reliability and low latency and productivity. And all of this comes back to, how productive can people be? Is this going to improve productivity for businesses? And that's where the money comes in. Yeah. If you can increase productivity by 5% by doing this, that's billions of dollars in utilization of manpower. Yeah. And that's worth it. So how to get that, how to implement this so that it does improve, productivity. And that's what we're talking about. How do you, what is it going to take to get it so that people are using this in their applications that will significantly improve productivity? So
the one problem with desktop as a service, I really think that, first of all, software doesn't belong on an employee's laptop.
Or stored data.
Yeah, data doesn't belong on somebody's laptop. And the ability to access data, to put it on a thumb drive, doesn't belong on somebody's laptop. That's a huge security risk. So to be able to get that away from somebody's laptop is a real benefit. But the question is, does that need to be on a desktop as a service type situation, or can it just be on a web access, software as a service type thing where, for instance, Salesforce, you just type in salesforce.com and you get to your version of Salesforce. Do you really need to have that extra layer of having your own sort of OS that you get to, that's your computer? Or can you just kind of have a portal through which you get to your applications that isn't quite the same thing as a desktop?
I think that lends a little bit into security, because if you physically have a device that you own, that your company gives you, that is essentially a laptop without an operating system, it's just a portal to the distributed mesh, then it's very inexpensive. It's very secure. It's more secure than your basic. You make it more secure than your basic laptop.
Yeah.
And and also it just, if you don't have this, you're not getting in. And if you don't have the right biometric security with the fingerprint and the code, it's worthless to anybody.
Yeah.
It has no value. So, and it costs virtually very little money. So then all of a sudden, from anywhere, you have this capability of running whatever system you need to run at any time of the day on something that's very inexpensive.
Yeah, I mean, to me, that's the only thing that makes sense. The question is, does that have to have this distributed mesh, or can you just have, regular Edge Connect style?
I think it depends on what you're at. Well, again, it depends on the application and what you're doing. But somebody who's doing scientific research on pharmaceutical or whatever, and they want to do that from a remote location, maybe they need something that has high, very low latency to say, hey, go run this and let me look at it. Obviously, the graphics are a big one. But that's to be, it's that, we are asking the question. Yeah. This is happening. Does it have value? And if it has value, when is that value going to be recognized?
I think it's the last one.
Right. Well, that's
yeah. I think there's definitely value, but when is that going to become like such a limiting factor? Because I know Netflix, for instance, they have gone back and forth of where they put their storage. They've had really for you little boxes that they put at a bunch of different places, and then they pulled that out and had their edge kind of more at these Edge Connect type places, and then there's this give and take about how much storage you want to put at a place, how much compute you want to put in a given spot, and it's not 100% clear which is cheaper. And
it's funny, even though like a Netflix or a big company, it's trial and error. You're going to have to try some stuff, and with this Kinetic type of thing, I think that over time people will try certain things. Oh, this particular application doesn't work here. We have to do it some other way. Oh, this is a new application, something we're doing that you and I can't think of yet, but it's going to happen, will work perfectly in this environment. And it's curious. Obviously, these folks are getting a tremendous amount of investment. Investments is speculative. You're going, somebody is selling somebody on the eye, give me millions of dollars, and I will build this because, and they give them a list of reasons. Yeah. And or is it all blue sky, or is it something that's real? Obviously, investors thinking it's real because they don't want to spend their money on something that's not. So they get convinced that, within the near future, 5 years, let's say, this will become a standard, a thing that is growing and needed. Are they right? That's any investors. They're always gambling. So,
well, are you right? And is this the right way to do it? Because it's it's one of those things that I think from everything I see about Vapor.io, and I'm sure there are others, and I feel like I should have done better research to find those people, but you have to have the right sort of secret sauce to make it all work together. And these guys seem really smart. But whenever you have a sort of blue ocean where there's no blood in the water and you're trying to get there, you might pick the wrong spot. And so if you can find that blue ocean, great. But,
Yeah, where are the sharks?
yeah, where are the sharks? Exactly. Well, where are the sharks and where's the food? Like, what if there's no krill or whatever you're supposed to eat in the spot that you're trying to get to? Like, what if the particular formulation of this kinetic edge, there's a lot of different ways to do it. You could have a 50 kW little pod that is extraordinarily vertically integrated, where the one company produces the hardware, the actual IT hardware, and the box and the cooling tower, whatever, the dry cooler cooling tower, whatever is doing the heat rejection, and owns the sites and all those things, and that can just be one company that does all that stuff. Or you could almost set it up like a colo, where cloud providers can put their stuff there.
Well, that's what obviously Crown Castle, they don't put anything on the tower that's theirs.
Right.
They're a RIT, so they're a real estate investment company essentially, and they just rent space on the tower to whoever cell provider wants to be there.
Right.
And I think that that's probably going to be the mentality of these particular kinetic data center locations. That that's what they're going to do. Oh, you want to put that there? Here, it's X dollars for you to put it there. You want to?
Well, that's Crown Castle, but couldn't somebody vertically integrate all the rest of the stuff?
Well, that's the good question. I mean, I think because these things are so relatively, can be relatively small, and you could put it on top of a building. You could put it it's could go anywhere. Depending on. Because you and I know that you can put something in the size of a drop-in freezer that has a tremendous amount of capacity if we get into the liquid cooling and the and then DC power and et cetera. That can go anywhere. So that's the question: is even having it go anywhere, is that beneficial? And we will do some research. You and I know we'll research this. And we'll find who's writing applications that needs this particular type of infrastructure.
Well, I'll throw out too, since we're sort of talking about the enterprise space and companies putting their data center someplace, having a hyper-converged data center that is real small really makes a lot of sense right now with things like Amazon Outposts, where you basically have your own private cloud that you're leasing from Amazon on premise. So to have something like that can just go in a little, single rack or something could conceivably replace most of a whole data center. Right. The way that some of these hyper-converged the computing, how that actually works is you can really shrink a lot, and you have much smaller compute nodes, and you have many more of them in one rack, and the better your cooling gets, the better that gets. And so maybe this isn't quite related to this concept that we're talking about, but being able to put really tiny compute nodes or storage or whatever at a customer's site.
Well, we talked earlier about the fact that these would be essentially part of the cloud.
Yeah.
And so those access points that you're talking about for AWS or whoever else, this may be, you may have one person, for your own building, and that's more dedicated to you and has backup and but there's also, like, say the more socially or more community oriented units that are out that aren't just on your property or just more, as we say cell tower or above on the top of a municipal building, that those are more for the community, and I think that's, again, this isn't going to be one thing. It's going to be it's going to be the idea of using this for different purposes, but access to the cloud and having your own, private cloud, which is, people don't understand that concept either, but having a private cloud that is also gives you interface to the public cloud or the, many things you don't need to go out on the internet for cloud, for your users to use the concept of cloud.
Right.
But it's instantaneously backed up and has all those, all those features that the cloud has, but it's on your property and it's yours.
Yeah. Well, Google just came out with something that's in beta, which is similar to the Amazon Outposts. That is, I forget what it's called, but it's basically Kubernetes in a box. So, and they lease it to you, or you lease it from them, and it's takes this sort of big hyperscale idea of being able to move your workloads wherever they need to go really quickly, and puts it in a box that Google kind of manages a lot of that back-end stuff.
Mm-hmm.
And so taking something that has that kind of smarts and putting it anywhere. But, I guess before I was thinking about this whole thing as a box at a cell phone tower, because we were talking about this Vapor.io. But when you start to get into a business doing it, that's a whole nother thing.
Mm-hmm. Right.
It becomes a different question if we're talking about a small business or a Fortune 500 business, or somewhere in the middle, to figure out where it makes sense to put their workloads and how you provision it from place to place, and how you do failovers, and if you have compliance issues, how do you ensure that there's that you're covered wherever you are. So
well,
let's say
the HIPAA requirements for hospitals and doctors and all that, these things can be designed to be specifically, designed around that requirement.
Right.
And there are standards for that. And it's a giant thing. People are every doctor's office is going electronic. So again, these things are not going to be this is the Kinetic, whatever, is going to be one part of it. The cloud access points are going to be another part of it. Specialized applications, high performance computing is going to be another part of it. But it's all shrinking. That's the interesting part of this. It's shrinking. It's giving you a certain access that is needed for your particular company, and it's also taking away from the company all the grief of having to run a data center, a traditional data center. As you and I know, companies don't do it well. They, it's much better, as far even economically, to do it as a service. It's, OpEx instead of CapEx. Those things are happening. I mean, that kind of pushes to the colo.
Yeah, this is kind of colo cloud,
But it's renting your colo. It's leasing your colo, but colos happen to be on your property. Somebody else takes care of it, and somebody else manages it, and it's very, very secure and very, very reliable. But
so let me see if I'm understanding your use case, because I don't think I understood it before. So you're saying that, let's say there's a company that has 5 different sites around the country, let's say. Then they would have one of these pods, each one of their sites. And if one of those sites has a problem, the other sites will take over, and it'll still be in their ecosystem. Is that kind of what
that'd be
an
excellent application for this concept?
Okay.
Because that's essentially their private cloud.
Yeah.
That's just for them.
And then if there's overflow, it could go to public cloud.
Yeah, you always need access to the public. There's things as as you talked about Salesforce and other types of applications that work very nicely in the public cloud. But if you have a string of hospitals in the Lehigh Valley, and each of those hospitals have certain requirements, and you can put one of these these devices, this box, data center in a box concept at each of those facilities. And then each of the people, the doctors and the providers, have their own link to that. It's a private cloud, but it's multi-location, and it's synchronous, simultaneously backed up from the other locations. So you're creating this, this distributed mesh, but it's a private distributed mesh, and the technology is there. Now, someone, Google and Amazon are saying, oh, we can give you that box and we'll maintain that box. And, you don't have to worry about having a data center in your space. You don't have to worry about going to some some colo and owning equipment in the colo that is your equipment that you got to go there and upload firmware and do all the things you have to do to the colo. That's more my thought of it, is that that's a place for this concept to go.
Yeah. Well, in a way, you're describing Amazon Outposts and that kind of stuff. And if Amazon were to containerize that, instead of, put it in a rack that requires cooling, to have it in a container that's self-contained, then that makes sense. So that, it's a lot to think about, because I was, I came into this thinking about the sort of larger scale, non-corporate type, or not necessarily corporate type of application. But so I think there's two different parts to it. But if you start thinking about the corporate use case, then it stops making as much sense for it to be at a cell phone tower location.
Right.
But then you have problems like, getting connectivity between the sites and having, like, setting up dark fiber and SDN or something that has fantastic connectivity, so that you're always having that failover capacity. And so
now what about, the 5G technology, the Wi-Fi technology, where your connectivity is really good, but it's not necessarily, dark fiber.
Well,
is that, the speed is an issue for
because even 1G isn't enough for 1 gig isn't enough for a corporate backbone.
Okay.
Let's say you're trying to do some kind of active corporate mesh. You're going to need a lot more data bandwidth. 1G is a pretty small corporate
10 gig
connection.
Is usually what people are kind of,
Yeah, and it gets complicated too, because if you're web facing, let's say you're a media organization and all your customers are getting to you from the web, well, you don't have to have that exact same continuity of the exact instance of something running. Like, you don't have customers typing on a laptop on a Word document and then that goes away. You have customers who are, clicking on your website and want to continue to get to your website. So that could move across the country and nobody would notice, for the latency issues and also for a lot of issues. So, having an active type of setup, it depends on your application where that makes sense.
Well, at the moment, these companies would all have very high quality internet connections to each of these sites. There's no question about that. Yeah. They'd have, and even if they're the smaller sites, they'd have an IDF closet or MDF closet that has, servers in it and have, certain, obviously their network that distributes their data throughout their space. So they're already, that infrastructure is there.
Yeah.
And it's, but it's just the fact that they have to, deal with these very cumbersome rooms that have, their, and the number of technicians and people that they have to service these things. And also to get we're very knowledgeable about colos, but they have their downside, with, and depend, some are better than others, but still in most cases, you own what's in there. And so you have to either pay somebody for the service of that, which gets expensive, or you do it yourself. This idea, and I'm sure that Amazon's, there's smart people out there, their idea of putting these micro clouds in people's buildings or in people's corporate locations, and then they are able to access AWS, they are going to spend the money on that because it makes sense.
Yeah.
And it comes back to, the data center as a service, not just failover as a service, disaster recovery as a service. It's the data center as a service in all regards. It's just that it happens to be within your, you have it on your property, just like you would lease a car or you lease a truck, or, those things belong to you for the time you need them, and other people service them, and other people take care of it from a maintenance and reliability point of view, which is what happens with colos. But why do you need to go to some building when you can, this infrastructure is getting so much smaller and so much more reliable, bring it, lease it.
Yeah.
That's.
That's
a point that I didn't think of before our conversation today, but it seems to make sense.
Yeah, I mean, well, I think that's where a lot of the industry is going right now is leasing assets, and you can lease a Cisco stack that's hyperconverged, or there's a lot of different, but usually they're rack. It's a normal kind of rack based system. And then more and more you can get like a standalone micro data center type rack too.
It can be a rack. I'm not saying it has to be. You can put it on a dolly and roll it into a room too. But having it as a little phone booth out out in the secured area also may make sense, as long as it's efficient and the connectivity to that is good. I use the term TARDIS in some,
right.
And of course only the Doctor Who heads will be out there understanding that. But putting a police box somewhere, and knowing that you basically have connectivity to the world through it, that's something we kicked around when we were talking about the distributed mesh data centers.
Yeah.
That your access is this box, and I always liked the idea. And back then was these would be located in commercial and industrial locations, along with schools and hospitals and other things. And in some cases, they're part of the public mesh. And in some cases, it's a private mesh, or a private cloud, whatever you want to call that. That's a way of looking at it.
Yeah, it's the question of, is it public, private? How does it all get together? It's overlapping a lot with the sort of cloud. It's almost like. So I feel like we've bunched a bunch of different things together in terms of what we're talking about. But I think these as a service, not just infrastructure as a service, but also on premise,
I call it data center as a service. I mean, it's
but then are you going to have an actual data center with perimeter crack units? Or are you going to have having something that is standalone as much as possible and super efficient at being standalone.
Well, that
makes a lot of sense.
My thing is that we know data centers. We've been dealing with data centers for many, many years, and we know that they're changing. Even, many of our clients have data centers that at one time were designed for 500 kW of IT load, and are now running at 150 kW. And the rest of that is dormant space, and it's you can take what's in that 150 kW and put it essentially in a box, and have it high efficiency, and it's a leased device, and you've gotten rid of all of the grief of having to play with all of this redundancy and all the data center issues. Not that I want to put ourselves out of business, because that's we deal with data centers, but if it's smart for the industry to go that way, it's going to happen regardless. We're just kind of thinking about it ahead of time a little bit.
Well, for our design business, we can just design the spots where we put these things and say, get ahead of the curve and be like, okay, you don't need this. Let's just use this little spot.
We're actually consultants, and we advise people on master planning their future as far as how do they access IT. And it happened to be in the past that it's accessing it through data centers. We're continuously working with clients to, get them to understand the hybrid model. Hey, what applications work in the public cloud? What applications work in colo data centers? And what applications work in your space? This is just another piece of advice that we, as the technology becomes available, we would advise them that this might be something they would consider. And as these companies produce these boxes, and they're high efficiency and have a lot of versatility, we would say, we're always looking out for the client's interest. So that's just another arrow in the quiver. that we can present.
Yeah, I think it's there are a lot of options on how to present to somebody about what they should do. I mean, you could, for a long time, everybody was just trying to build the best data center on premise. And that, I think, pretty quickly was obvious that it wasn't the best way to do things. But that doesn't, but now, since everything is getting squashed together, and since development and the people who are actually, working on servers are getting more and more involved in the back end of things and the actual physical infrastructure, and with DevOps and the mindset of provisioning based on what's actually needed for the software, it all has to be integrated from the design side too. And I think the designers of data centers really need to keep up, and I don't know if they have, with that mindset of thinking about the convergence and modularity, not just in terms of having pods, but modularity in terms of being able to take a whole rack and plug it someplace, and being able to think about things in a failover and having assets at different sites. And
one of the things that if you're leasing this box, you have a command center that people are looking at all of the infrastructure associated with this thing full time, 24/7. And it's their responsibility to make sure that it's both up and running from a physical point of view, but also from a connectivity point of view. And so, this is all becoming something where it's a utility, just like, the electric, there's a transformer out on the pole near your building or on your property that is, transforming that high voltage into usable voltage in your building. This is essentially the same thing in concept, but a lot more technology involved. And I think the industry's going there. I don't know. It's just, why not? Other things have gone.
Well, I'd say it's already there for a lot of things. It's just who's going to win. Like Oracle is trying to do this, and there's a lot of every one of those big companies, big IT companies, are trying to win the war of the hybrid cloud.
And that's good, because then it becomes more competitive.
Yeah.
And our capitalist mindset is that if you get many people doing things, the people that do it well will get a large share of the thing, and other people will create, will have methods that make it more sellable, and people will, that feature I really like, let me use yours. I think it's important that there's that there's standardization across the platform, and there are associations that help do that. I mean, we were talking about open source and other things, but the Dells and the HPs and the Oracles and, obviously the Googles and all the world are going to really jump on this. But there's windows for small entrepreneurial companies to provide specialized versions of this.
So I think that brings us back to this Vapor.io. Their specific vision was to have a city scale Kinetic Edge, or we'll say distributed mesh, to have 30, 50 pods, however many, that are around a metro area that can fail to each other and achieve high reliability that way. And we haven't even talked about how they're trying to do that with containerized solutions, and then they have this airflow system that they like. But the question is that kind of city scale sort of micro cloud, whatever that sort of mindset, is that going to be the winner? And I think what we came down to is that's not clear. That it's a very good idea, but
I don't think there's going to be one winner, one system that's going to be universal for any city or any situation. There's going to be different methods for different purposes for different types of users. But what they're talking about makes sense, I think, today. The technology is there. It's a question of whether or not how expensive it is to implement, and how many users are going to buy into that. And that's what their investors are obviously looking at. And as it gets more competitive and as more people do it, hopefully the cost gets more reasonable. But the cost has to be justifiable today as compared to what you're doing. If you own your own data center, if this reduces the cost of accessing AWS, for everything, and but it reduces some of those costs, then it has to be cost justifiable.
Yeah, there are some ways in which you could save just bandwidth costs if you are if I'm only traversing from my house to the cell phone tower and back, and that's the only kind of data that's being transferred. That's all you have to pay for, and you're not paying transit all the way back to your core data center. So there's cost savings, but it's a very specific case. Well,
it's also that if you can get what you need from an application point of view within this pod, that's close to you, you're not making the big internet system clogged with having to go all the way back to some central point and back again.
Yeah.
So you're making the highway less traffic.
Right. You're letting people have home offices as opposed to having to commute to their offices. It's so the big highway doesn't have to be as big because people aren't traveling on it to get to their office.
We've been able to reduce the cost of building the internet interstate, let's call it.
Yeah.
But it's still expensive to maintain and everything. Whereas if people can, when you need to be on that interstate, it's you have access to it, and what's already built is adequate for many, let's say a generation. Then all of that money, this may reduce the need to make that system even larger. And we have associates that are building the fiber highway through the York Reading, direction outside of the 95 corridor, and that's good. That's for redundancy and capacity. But all of those things are finite. There's this limit to all of them.
Yeah.
And if you can, put this kinetic edge or distributed mesh, and you just need to go these short distances to get what you need, then that's all the better.
The last kind of painful part is that there could be another disruptive network technology that destroys all this, because Elon Musk is trying to put satellite, like 4,000 satellites in the sky that communicate with each other with lasers and shoot lasers down into the ground, and that would have almost zero latency,
they may
speed of light transfer. So they would probably need these pods at one of those points, maybe. But
they don't want to go to every business, every home necessarily. They want to go to some place and then spread out from there. But they don't necessarily want to go to mega data centers.
Well, I don't know. Yeah.
Well, he's a smart guy, so he's going to figure that out.
So I think we touched on a lot of stuff. This idea of the kinetic edge is very interesting, and we're excited to see where it goes.
Yeah, I like that. If there's some ideas that popped in my head that I never thought of before, so that's always a good thing. So
yeah, that's why we have these conversations.
Thanks a lot.
That's our show. I'd like to thank our guest, Kevin Farnsworth, for coming on, and I would like to thank our sponsor, Greenlight Design. I'd like to thank Juke Deck for providing our theme music. And be good, everybody. And I'll talk to you next time on the podcast.